Awesome. Good morning, everyone. That was me sorting out with the demo gods. That would probably allow me to be a little streamlined for the next couple of minutes at least. My name is Harsha. I'm an associate manager in Red Hat. And I wanted to share a bit of a learning from Kube-burner. Kube-burner is one of the open source projects that I have been using to performance test and understand the limitations of my Kubernetes, let me put it that way. The name is interesting. It literally actually burns your cluster, in the sense how much can you push it, how much could you understand the limits of it, and how do you go about it from there onwards. Just to touch base about where I am. So my name is Harsha. I'm an associate manager in Red Hat. It has been near about 4 years with Red Hat, and then currently I work in site reliability engineering space, double coating reliability. And then before that I was with IBM Software Development Labs, where I was working as a performance and scale engineer. My interests have translated where I was working on distributed systems before, and I wanted to work with Kubernetes, understand much about how Kubernetes is actually solving the problem at many of the places. But my interests have been specifically aligned to doing more with less resources. So in continuity to what I mentioned, reliability, right? Reliability in today's era has been associated with customer experiences. So I work with my team, which focuses on improving the customer experience. If your product is very reliable, customers will tend to use it. So how do you define reliability? The experience that you have with a cluster at 3 nodes, and the experience that you have with a cluster at 255 nodes or 500 nodes or 1500 nodes, it should not change. But I think we have been trying to solve this problem and understand, because it is Red Hat and because it is OpenShift, we have been trying to solve this problem in very early stages and understand the limitations of the OpenShift cluster. But the learnings are could be translated. Kubernetes and OpenShift, all the skills are translatable, right? They are interchangeable in general. Before I get into the what is Kubernetes, or what is Kube-burner, how Kube-burner works, and we started understanding the foundational question, which is, what is a distributed system? It's a complex interconnected system, but for user, it's a single entity. They submit a job, it gets spread across different nodes, edges, and it provides an information back. While designing a distributed system, we have different topologies to make use of. There is a mesh topology, there is a ring topology. Okay, good. And please do let me know if I am not loud enough. I tend to speak a little low. I definitely had my breakfast. I definitely had my tea. But please let me know if I am not talking quite loud as such. So again, we started understanding what is distributed system. There are different ways to represent it. Again, solving a problem using interconnected nodes and getting the, and then for user, it is a single entity as such. What are the couple of traits of a distributed system? Could anyone tell us? It could be anything or anything in general. What makes a distributed system? What are the characteristics of a distributed system?
We definitely would need a controller who could see, like if it's a master slave architecture, we would definitely need a controller.
Of course.
Who needs to manage where the work is being done.
Mm-hmm.
We definitely need, if we send a request to a node, we need to know if the node is died in the middle. So how to reschedule. So scheduling needs to be taken care of. And we also need to take into consider the network latency, because it's not a single mission, there will be a network latency when there are distributed systems involved.
So fault tolerance in general,
yeah.
Right? When I submit a job, it should come back with responses. Scalability. Let's assume, off late I have started developing a taste for walnut cakes, and if I have set up a shop of a walnut cake, and I'm catering to different users as such, And for the benefit of the doubt, I'm not really good at businesses in general, but if the requests are coming in more frequent, I need to build a system which can continue to provide the similar experience that I have with 1 users, 10 users, 100,000 and more. So fault tolerance, scalability, the experience should not change with my shop in general. Of course, scalability, latencies, fault tolerance in general, right? So we try to understand the same problem with Kubernetes. Kubernetes is really beautiful and it can be really complex as well. But when we try to understand the problem, we should divide it and understand what are the limitations of my control plane, what are the limitations of my data plane, what are the limitations of my networking. And then that's exactly where a necessity came into picture, and that's where the Kube-burner as a tool came into the aspect. Kube-burner is an open source tool. It is available in GitHub, available for consumption for everyone. It is written in Golang for the ease of consumption. And right now, we have been using Kube-burner not just for OpenShift, we have also shifted it to Kubernetes as such. What does it mean? It's a tool with which we can orchestrate workloads. We can orchestrate workloads in the sense there's a customer workload. At the end of the day, each of these workload is represented in form of Kubernetes objects. If we understand from the telemetry data what those Kubernetes objects are, how many objects are we creating per hour? In that object specification, how many are pods, how many are services, how many are routes? If you capture all that information and provide that as a form of a YAML to Kube-burner, it will orchestrate it across your cluster. And I said emphasis on end-to-end. So we start the workload, we end the workload, we also capture information which is related to observability. How was my system behaving during that time? What are the choking points? So we look at these anomalies, we try to identify where the choking points are. We could apply some of the logging tracing mechanisms, go back to understand where the choke points are and try to solve it. If you have custom measurements, like if you have an application which does not traditionally make use of node exporters, but you have built your own custom node exporter for that matter, we could use some of those metrics to consume those measurements perspective and key in that information inside Kube-burner to do that end-to-end job in terms of running your workload, capturing the observability, capturing your metrics during that time and indexing them and go on. This is a busy chart, but I'll try to keep it very high level and I'll try to talk from different personas. One of them is architect, one of them is application developer, and then the admin, right? For an application developer, the interesting aspect would be whatever platform I have been provided with, I need to know the limitations of my application as such. Provided there's a 3 worker node setup, how much my application could scale, what are the latencies of my application, and then in terms of Kubernetes, how many pods I could run in a distributed manner for that matter, right? So Kube-burner could simulate, Kube-burner can simulate some of these problems, and then all you have to do is understand how many objects we are creating, point it to the right image, and then capture all of that information into a YAML file and pass it along to Kube-burner, and it will orchestrate it for you. From an architect perspective, capacity planning is very essential. I understand there's a lot of advancements with autoscalers. You could scale up, you could scale down, vertical autoscaling and everything as such. But the core of capacity planning provides a beautiful essence where I would know at what duration of the year I should probably scale. This would provide insights into how my cost for the year will look like. And then if there are any areas of improvement in terms of optimization, I could do it as well. For architects, Kube-burner could provide that extrapolation where if they have run a workload at 3 nodes, 24 nodes, 120 nodes, we could characterize and understand based on the data points and tell that, hey, this is the limits of the application, these are the limits of your platform. Anything beyond that, you need to spill over into a new cluster for load balancing purposes. For admins, the baselines, right, and in terms of service level indicators for that matter. What is a baseline performance for my system? if there are a lot of application that is running in and users are not able to log in, we need to understand how many users can simultaneously perform similar action on the system. All of those things are really good to know, because sometimes being in site reliability engineering, we get to have a lot of exposure towards incidents where, of course, a lot of those things come down to the fact that there was a poor capacity management at places. How could we solve those things? So I think that's exactly where we have started recommending, go take a look at Kube-burner. You could orchestrate your workload. You will understand the limitations of your application. You could understand the limitations of your platform and go about it. We started doing these exercises on very early stages. In fact, before releasing the GA of a Kubernetes, we have interim releases or nightly releases or release candidates for that matter. We started doing some of these exercises on those releases. What we fundamentally started doing is the feedback loop that we started understanding. All the control plain tests, all the data plain tests that we used to do before on GA, we shifted them immediately to the nightlies, which allowed us to get a feedback loop quicker. And we understood, hey, these are the choking points. We need to fix this even before the GA date comes and hits us. So performance and scale has been an essential problem, and then sometimes the forecast problems which might have occurred if you had left it loose, and then go about it. So some of the key questions that we tend to answer is, how much load can my application take with a fixed amount of worker nodes? And then how many pods can my system accommodate overall, right? And then how many VMs, if there is a virtualization at the core of the discussion, we could also ask how many VMs could be scaled up. And when we do this comparative analysis, we try to do the comparative analysis between the Kubernetes version 1 versus the N-1 version of it. So this way we will understand where Kubernetes version is improving, and if there are any choking points, we should be able to solve those problems earlier. Okay, I think while don't look at the flowchart in general. For Kube-burner to work effectively, it needs a kube config, and it needs a YAML file that represents your workload. And YAML file, we all are familiar with YAML file, if not JSON file, right? We could represent our workload in a YAML file and pass it along to the Kube-burner, and it will do its stuff easily for you. Sometimes nature of jobs are, we need to do some sort of churning. The workload is never consistent. There are, if you have a platform, the load on your platform varies throughout the day. It could be active on the mornings, it could be little easy during the evenings, and it could go better or silent during the nights as such. Again, this is just a perspective. So we try to make use of something called as next job, where once the job is completed and we want to perform churning, it will do a portion of churning where it will recreate the objects again by a percentage basis. If you want 10% of the workload to be recreated, it could do that. Why? Sometimes CPU can get freed up and it cannot, it could be little easily guessable. But when we start hammering it down on a consistent basis, we also have noticed that Kubernetes could at times behave erratic. And then we try to solve these problems a little earlier in the whole of the OpenShift cycle. While I have emphasized quite a lot on creating jobs, understanding the nature of workload, and running through Kube-burner, it is also important that whenever we run this workload, we capture this information into our Elasticsearch servers. And then what information we capture? We typically capture how my CPU was behaving, how my memory was behaving at node level, at namespace level, at pod level, or at every granular level. We capture all of that information, we index it to a choice of Elasticsearch or an OpenSearch, or you could do it into your local systems as well as a local file format, and you could analyze it. You export all of that information and then try to look into your Grafana. It will start giving you visualizations. Those visualizations, the easiest way is if the graph has a repeated pattern, it's good. If the graph has really big spikes where we need to understand what's happening. We take the time slice and dig into those details. Again, so this is Kubernetes accepts declarative syntax information. On the right is a config file. I want our attention at 3 places: metric endpoints, jobs, and global. Global is a section where we want to, where we specify what needs to be measured. If you're trying to just understand what is the pod startup latency, where I bring up 100 pods on a node across 120 nodes, what is my pod latency, how quickly my application will come up. That's exactly where the measurement aspect of it comes in. For metric endpoints, we need to scrape. So we need a metric endpoint on where we need to scrape it. And sometimes we need to capture the alert information if there is any alert information as well. We need an indexer. Where do we want to index all of this information towards? Jobs and objects are, in fact, representation of your workload. And there are a couple of workload information that's already provided. In this case, it's a node density CNI. We are trying to hammer the network portion of the system. And then we are trying to create near about 50 job iterations. And yeah, and then we are trying to do 10 jobs in a namespace kind of a thing. I can show you a demo later on, but at this point in time, so Kube-burner can do a couple of jobs over here. It could create a job, it could recreate a job as well, and it could delete, it could patch as well. That's what I meant by recreating the job. When we create a job, we could specify how frequently we want to create the job. Do we want to create it every 20 milliseconds or 10 milliseconds? This way, we will be hitting the Kube API server limits. And this way, we will be able to understand what's the limitation at the Kube API server as well. When we try to delete a job, not always we want to delete in a really nice scaled down manner or stepped down manner. We sometimes want to do bulk delete. Why? Because this will emphasize the delete verb on the Kube API server. When we do frequent deletes on the cluster, it hammers your Kube API server. We will understand what's happening when the Kube API server latencies are improved, and how do we go about understanding why the latencies have improved as such. And this is one of the nice things. Not everyone will have a similar workload requirement. We also allow users to bring in their own workload, where we could do custom measurements. For example, not everyone would want to run their application in form of pods. Some of us would want to run in form of virtual machines, right? There's a whole concept about KubeVirt, and then how do we bring up the entire virtual machines, and then what are the latencies associated with the virtual machines over there. So in such cases, you can bring in your own custom measurement metrics that would allow you to understand how your system is behaving, and you could answer these questions from architecting perspective or developer perspective in general. So pprof, anyone who has done flame graphs or anyone who has done profiling understand how it is important that we get the insights into the systems using pprof. So Kube-burner has, you just need to provide an extra argument, and it will do the pprof profiling. It will capture all the dump information. You need to analyze it through flame graphs and other stuff. This is for advanced performance debugging, where we understand how things are going as such. Yeah. Okay, so OpenShift wrapper. On top of Kube-burner, which is specifically catering to Kubernetes, we have an opinionated wrapper on top of Kube-burner called Kube-burner-OCP. What this does is it allows us to stress the Red Hat OpenShift platforms, which is there in AWS and which is also there in Azure, which is also there in GCP for that matter. We have different workloads, each of them performing different set of expectations. If you want to understand how quickly my pods come up, I'll use a corresponding workload. If I want to understand how quickly my full stack applications come up, I have a different workload, which is intensive, where we need to understand a DB comes up, my front end connects to it as well. So similarly, there is also the virtual machines concept, and we call it word densities, where we create some ephemeral VMs to understand the latency startups and so on and so forth. And Red Hat has been really big advocate and adopter and exerciser of open source tool. And most of the work that Red Hat does is at open source. Everything that we build is in the GitHub. Everything that we do starts in the aspect of community. And most of the conversations, any issues that we raise are there in GitHub. Any conversation that happens are there in form of PR discussions or issue discussions. And we try to have, we have a office hours where people can join in, ask questions. They could ask questions on how we can contribute and how we go about it. Right now we have close to 700 stars. Yeah, close to 700 stars as of yesterday night. But this is a CNCF sandbox project. We are working very hard to move it to incubation status. We have observed really good contributions across different, consistent contributions across different organizations, not just Red Hat, IBM, and we also have folks coming in from Yahoo, Enterprise DP, and Upbound. They started contributing to it because they found value in their institutions on understanding what the limitations were there with their application, and they have gone about it from there onwards. All right, if I'm going to be super quick with the demo, and if the demo god allows me to do it. Can you see my screen, or should I zoom it in? I can zoom it in. Good enough? So this is a Kube-burner OCP binary, and I'm trying to run a cluster density test. Cluster density test, in a nutshell, is a full stack application that brings up a DB, that brings up a front end that needs to establish connectivity with each other and see how the application runtime comes up. What I'm going to show you is I'm going to run 20 iterations of it and use the churning mechanism where once the workload is established, it churns a portion of the workload very frequently for every 2 minutes to understand on the long term how it goes. Why am I doing this? This is all about stress testing, right? So the moment I start running this, it does some pre-checks, and then the moment the cluster density comes up, I'll show you in the Grafana dashboard how the spike is loading up. All right, I think I just wanted to be making sure that the demo gods are with me. So I had done some pre-runs at 10:20. That's where you would see these nice spikes, which were hammering the CPU of the systems. While it is less than 1 core, but you get the feeling of it. The more iterations, the more knobs that you tune, this will be more intense, and you will see the graph to be very consistently high, and it gets flattened out. And then the moment you start doing churning, it will dip, and then it will go up again. But in translation, when you look at Kube API server's logs, you would see a frequent number of lists or create or delete objects happening. And this is again CPU measurement. You will do something similar with Kube API server latency measurement that would allow you to capture this information and go on to see if there are any breakages in terms of latencies. And if so, we will dig into the details of it and come back. So this is one of the ways that I found Kube-burner is very useful, not just from performance and scale testing perspective. I have used this in our reliability aspects of my systems, where I wanted to understand if I break my system, how do I respond much quicker, much better. So while I could do it with a mix of Kube-burner as well as chaos engineering, where I introduce chaos along with a load and see how my systems behave, and then go about it. So if you see this spike over here, the last one at 11:35. That's one of the reasons why the spike is because the workload is starting in its place and it is continuing at this point in time. Yeah, so it's creating some iterations and waiting for the actions in the cluster density namespace to complete. Yeah, and this is real time. So this is just less than 2 minutes. Things are just bringing up. Once this ends, I would, and then once I have provided my indexer, all this information will get indexed into my Grafana. I'll open up to see if there are any differences. What I'll see is, given that this is an intense workload, I would want to see how my Kube API server is behaving. And if any of the responses are more than 1 second, I will dig into the logs to understand where the issues are coming up and how it is going on. So I also mentioned an aspect of churning. You would see below the namespace 15 and 16, they're getting terminated. They are a portion of 10% of the workload that I have initiated. It will get deleted, it will get recreated again. So that was a demo that I wanted to show and go about it from there onwards. All right, if you have any questions, please let me know, but I want to do a time check and see how we are doing overall.